We're going to look at ray tracing in a flat mirror first, a plane mirror. The first thing I want you to see, now since I don't play well with others, I'm having to hold the mirror by myself, so I've just mounted it in this vice stand. This is the back side of the mirror with these hash marks. This is our perpendicular to the mirror called the normal. I put it on there for you for one of two reasons. You can decide it's either because I'm being really nice and helping you with time, or I have no belief at all that you guys can draw a right angle. So it's up to you. Now I shoot the ray in straight. When I move the mirror forward to its position, it also has to be 90 degrees to that. And one of the ways you can tell is, does the ray come back on itself? Now, if you look here, I'm going to deliberately tilt the mirror out of line. You can see the reflected ray is wrong. Sometimes you may not see the ray, and that's because your mirror is tipped backwards, like this, and it's reflecting up, or the bottom of these ray boxes is warped from the heat. And again, the solution is to tip the mirror downwards till you see that beam. Now that I can see the beam, I can rotate my mirror right here to the beam's coming back on itself. And that means I'm 90 degrees. And there's a reflected ray. Now you're going to send this in 3 different ways. This angle, and then I'm just going to swing to an arbitrary angle out here. Very important that the beam hits the mirror right at this vertex where the normal and the ray strike. Because otherwise you can't use the line I gave you. You have to start using a protractor freehand. Really obnoxious. So I'm going to mark the ray going in like this, and I can see it coming out here, and I'm just going to put a mark there. All right? I did not attempt to freehand the whole beam. I just put a mark. I'm going to do that 2 more times. I'm going to go out here. I'm going to put a mark where it was going in. I can't see the ray too much, so with a little bit of care, I'll have to play. So there it is. It's because this ray box is warped. I lift it a bit, and I can see the outgoing beam. So it looks to be about there. But since I tampered with the mirror, I better double check. Did I bump it out of line, or is the beam still going out? Looks like the beam is still straight, so I'm pretty good. That beam going in, if I can't see the outgoing ray, you can just sometimes lift the ray box a little bit and see that beam. So I'm off a little bit, aren't I? No, that's about it. So I'm not going to be able to tell these apart later. So I'm going to mark this one with a number 2, a number 2 here, and I'm going to go through my 3rd beam way out here. Farther away from the mirror I can mark, the more accurate results I'll get. Now where's the outgoing beam? Again, I lift it and I just peg the middle of the beam. How come I didn't draw the rays on? Because it takes forever to draw them on freehand. Now you just have to do this. I take this here. That was ray 1 going in, and it bounced out to here. Ray 2 went in this way. Came out there. Now, almost. I'll use this. And I've got my rays done. Now we have to measure them with a protractor. The protractor, of course, has that horizontal line there, and it's got its perpendicular right here. So I use that on the front edge of the mirror. That's the center for the protractor. So this part of the protractor right here, that central hole, needs to be where all the rays join. So we're looking about there. Okay? My 90 degrees lines up. First thing you're going to want to do is you're going to go from your 0 and you're going to count up and get 31 degrees. No. You're measuring this angle from the top down, that away. So we're not going to write this as 30. We're going to write it as 60. Like that. Thought I was starting at 2, didn't you? No, I was just confusing you. So it went in at 60 degrees. It's the complementary angle, not this one, but from here. We'll see why later it's done that way. So if I want, I can just count 10, 20, 30, 40, 57 degrees. So 57 degrees out. I could have gone this way and gone 10, 20, 35, and then just taken it away from 90. So let's take ray number 2. 10, 20, 35. So it was 35. And on this side, 10, 20, 33. It went in at 33. My last angle is 10, 20. And it came in at 10 and 15. So these angles are nearly all the same. The angle that went in was the angle that went out. So what we have for these ray diagrams is angle I is equal to angle R on flat mirrors. And this is no surprise. If you were playing a game of squash or some kickball against the wall, and you stood here and kicked the ball so it hit the wall at a 30-degree angle away from perpendicular, it's pretty obvious your friend would have to stand here and they would catch the ricochet at an equal angle. And you would all be quite surprised if you kick the ball and it took off like that. So there's no magic to flat mirrors. They're as you would expect. So it's a very simple idea of getting in and out. When the mirror shape is not flat, that's when it gets really cool and awesome.